Hello everyone, welcome back to my channel. In today's video, we are going to solve Leetcode problem number 145, that is binary tree post-order traversal using a very simple recursive approach. So that by the end of this video, you will be able to solve similar traversal problems confidently. So let's get started. So the problem says given the root of a binary tree and we need to return the post order traversal of its nodes value. So in simple words, we have to visit all nodes of the tree and post order sequences and store them in an array. So let's see the intuition. So basically there are three popular DFS traversal, that is in order, pre-order and post-order, and we have already covered the in order and pre-order traversal in my previous video, so please go and watch those videos too. And we're going to cover post order traversal. So in post order traversal we need to follow this order, which is left, then right, then root. It means we're going to visit the left subtree, then we're going to visit the right subtree, and then we're going to add the current node value into our result. So let's suppose we have this a simple binary tree. So according to this order, firstly we need to traverse the left side of the root node. So we have this is the root node, right? So we need to traverse the left side of the root node, which is this. Means we need to traverse this subtree, and then we need to move towards the right subtree, and after that we need to add this root node, right? It means if we're going to traverse the left side, means we're going to consider this subtree, right? So in this subtree, if you're going to see, this is also here also we have a root node, then here also we have a left child, here also we have a right child. It means we're also going to follow the same order for this subtree, right? So this is going to be our root node, this is going to be the left node, and this is going to be the right node. So according to this order we need to move towards the left node right now. And if you're going to see, we didn't have any other or any further child for this node, means this is the leftmost node for this whole tree, right? So I'm going to add them. So here I'm going to add this 4. This is going to be the leftmost node, right? Now, so this is our root node, right? So we need to move towards the right side of this root node, right? Because we have already taken the left node, then we need to consider the right node, right? So this is going to be the right node. So we're going to add this too. So I'm going to add over here 5. And after that we need to add the root node, right, which is this. So we'll need to add this node. So I'm going to add this. It's going to be 2. Okay, so if you're going to see, you will see that we have already traversed the left side of this root node, isn't it? Means we need to move towards the right side of this root node, which is this 3. So I'm going to add over here 3. I hope you all guys understand this. And then we need to add the current root node, right? So I'm going to add this, which is going to be like this. This is how it is too simple to do this. And now let's see the coding. Basically we're going to use a recursion. So let's see the coding part. As we know, the return type is list, So we're going to make a result list. So I'm going to make this like this. Okay, and because we are going to use a recursion, so we need a helper function for that. So I'm going to make a function def. I'm going to name them post order, right? So that's going to be easy to identify this function. Okay, and now we have an edge case. For example, if we're going to consider this node, right? So for this node, we didn't have a left child, we didn't have a right child. For similarly for this and similar for this, right? So we don't have to move further. We don't have to check for the left child or right child, isn't it? So if we didn't have a node, or the value of the node is going to be null, so in on that time we're going to return, right? So if not node, if node is going to be null, then we're going to return, right? And now according to post order, firstly we need to traverse the left side, right? So for that we're going to call this function post order, and then we're going to pass node dot left, right? Means going to traverse the left side of this root node. Then we're going to traverse the right side of this root node, which is going to be node dot right, and then at the end we need to append node dot well, right? So result dot append node dot well, and we need to call this function. So I'm gonna write over here post order. We're going to pass the root value, and also we're going to call this function. So return result, right? So let's run this code. Accepted. And before submitting this code, let's see the dry run. So basically we have this a simple binary tree, and we know that we need to pass the root node. So I'm going to pass over here 1, right? We're going to check whether this node is null or not. So this node is not null. Then we're going to call this function again. So I'm going to call this function, and this time we're going to pass node dot left. So what is the left value for this root node, which is 1? It's going to be 2. So I'm going to write over here 2. Then again we're going to check whether this node is null or not. So no, this node is not null. So we're going to again call this function, that is going to be node dot left. We're going to pass the node dot left value, which is going to be this 4, right? So I'm going to pass over here 4. Now again we're going to check whether this node is null or not. So no, this node is not null. And then again we're going to call this function. So I'm going to call this again, and this time we didn't have a left child for this 4th node, right? Look at over here, in tree we didn't have the left child. It means we are just passing the null value, isn't it? So if we're going to check this condition, that whether this node is null or not, so this time this node is null, right? So we're going to return back to this function, means this function is completed, right? Now let's move towards the next function, which is going to be post order node dot right, means just passing the right child for this 4th node. Look, we didn't have the right child, we didn't have, means again we're going to call this function, and again we're going to pass the null value, right? Means this function is also completed. And after that we need to append the node dot well, which is going to be 4. So I'm going to append this inside of a result, which is going to be like this, isn't it? Now this function is also completed. And after that, means this function is completed. Now we're going to move towards the post order node dot write. So what is the right child for the second one, which is going to be 5? So we're again going to call this function, and this time we are not passing 4, we are going to pass 5, right? Then again we're going to check whether this node is null or not. So no, this node is not null. Then we're going to pass node dot left. So we didn't have a left child, means again we're going to pass the null value. Then node dot right, we didn't have the right child as well. Then we're going to append this node inside our result. So it's gonna be like this, it's going to be this 5, right? Means this function is also completed. And after that we're going to append result dot append node dot well, which is going to be 2. So I'm going to append this over here, it's going to be 2 more. Now this function is also done, right? Now node now we're going to come towards this function, that is post order node dot write. So what is the right node for this first node, which is going to be 3, right? So we are just calling this function, and this time we're going to pass 3 over here. Then we're going to check whether this node is null or not. So no, this node is not null. Then we're going to call this function again, and we're going to pass node dot left. So we didn't have a left child. Then node dot right, we didn't have a right child. Then result dot append node dot well. So we're going to append this, which is going to be like this 3, right? Means this function is also done, this function is also done. And then result dot append node dot well, means we're going to append this 1, right, which is going to be our root node, like this. And this function is also done, right? So this is how our dry run gonna be looks like, and this is how the recursion going to be work in our code. Okay, now let's submit this code. So basically the time complexity for this algorithm is going to be big of n, because we traverse every node, and space complexity is also going to be big of n. Here we have used a stack, right? And that's how we solve Leetcode problem number 145, that is binary tree post order traversal using recursion. So if this explanation helped you to understand recursion and tree traversal, so don't forget to like this video. Also comment your doubt below, subscribe for more Leetcode and data structure tutorials.